In Earth's natural carbon cycle, carbon maintains a dynamic balance across different spheres. However, since the Industrial Revolution, the large-scale use of fossil fuels has rapidly released greenhouse gases into the atmosphere, disrupting the carbon balance that had been stable for thousands of years, leading to global climate deterioration. The essence of biochar is to convert fast carbon into slow carbon. Untreated biomass decomposes in the soil within years to decades, and the carbon quickly returns to the atmosphere, whereas biochar has a stable structure and can remain in the soil for thousands of years. The main ways biochar influences the carbon cycle are: biochar can combine with soil minerals to slow down microbial decomposition. At the same time, the increase in soil carbon content can enhance soil fertility, thereby boosting plants' ability to absorb carbon through photosynthesis. The porous structure of biochar can absorb organic matter, reduce the mineralization of native soil carbon, inhibit soil respiration, and decrease methane emissions produced during ruminant digestion. During biochar production, syngas is generated, which can be used as a high-performance fuel to replace fossil energy. This helps avoid methane and carbon dioxide emissions that would otherwise be released during the natural decay or incineration of raw materials. Beston provides end-to-end support to help you convert the carbon sequestration potential of biochar into verifiable and profitable long-term results.